reminder that whenever you are looking for an exponential function, we start with y equals a b to the x, okay? This is a half-life problem, which means that we get to choose what our initial amount is, and then by that choice, our final amount will be determined. So I'm going to choose that my initial amount of uranium-234 is going to equal 1, which means that the half-life, the amount when half of that time is over, is, or the half-life is 0.5. And so we know that with that information, we can solve for B, because we know that the half-life is 245,000 years. So the x value is our time. That's kind of typical in these kinds of problems. So we know that all that we have left to do now is take the 245,000th root of 5, okay? I'm going to see if I can write that in here for you so you can actually see it, okay? So 245,000th root of b to the 245,000th power, and then we have do the same thing to both sides here, and we've got 0.5 here, okay? You see that I've taken the 245,000th root of both sides. So that is equal to, over here, is equal to b. Thankfully, that was our goal. And then for this value, now you should leave it in your calculator, but it's going to be, even if I took it out 5 places, it was 0.999 for me. But leave that value in your calculator so you don't lose it. Now, so this is our exponential function, okay? So our exponential function is y equals a, actually, we determined that this was 1, right? So we had 1 times b to the 245,000th power, okay? Oh, goodness gracious, I'm getting this all wrong. Let me fix this. This was a 1, but then our b value, I'm getting this messed up. Our b value was 0.9999 to the x power. My bad. Okay, so there is our exponential function. Now we need to use that function to find out how much of a 150-gram sample will be left after 182,000 years. Remember, the y value is, if it's a, obviously it's decaying, so the y value we would expect would be less. So our initial amount, so we have y equals a b to the x power. In this case now we have 150 as our initial amount. We know that our b value is 0.9999 to the what power? It's 182,000 years. 182,000 years. And we want to know how much is left after that time frame. Now, I'm suspecting if you did what you were supposed to do, you still have this decimal value in your calculator, right? Well, all you have to do is just raise that to the 182,000th power, multiply that by 150, and you should end up with approximately, I'm not sure. I got 89.6, but I'm suspecting that you guys might get something different because I think I used a rounded value for this. Either way, show enough work that I know what you did and try to avoid rounding until the end. This is going to be 89.6 grams. And that makes total sense because it is decaying, exponential decay, right? So we had 150 grams, now we have 90 grams. Exponential.